Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Tutor Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, we shall be discussing temperature regulation in amphibians. Of course, amphibians are animals that live in water and moist or wet land and never on dry land. They cannot survive on dry land, okay? They have the ability to survive, or they live in both water and moist land. The first thing you must ask yourself is, are amphibians ectoderms or endoderms? So please, amphibians, reptiles, and insects are ectoderms because they do not have the ability to produce their own energy or heat in order for them to regulate uniform body temperature. However, if I'm saying that ectothermy is a phenomenon in which organisms are not capable of producing their own heat or energy in order for them to regulate their body temperature, I will be very, very wrong. Do you know why? It is simply because there are some reptiles or there are some ectotherms that can actually produce a little amount of heat or energy. A good example is python, that is Python morulus. All right, python undergoes a process called thermogenesis. This thermogenesis is actually a phenomenon characterized by the contraction of the muscles of the python, therefore producing heat endogenously. All right, though the heat produced or energy produced is in minute quantity. Please, you don't say that they do not produce heat or energy. No, it will not be correct. Another example of reptile called the monitor lizard, that is Vanarus gordi. It produces a very large amount of heat or energy in order for it to regulate its body temperature. So I just gave these instances for you to know that it would be wrong to say that ectotherms are animals that do not produce heat or energy to regulate their body temperature. No, just that most of them do not. All right, a few do. Take note of that. Now, amphibians being ectotherms and they live in both water and moist land. For them to regulate their body temperature, they have evolved. Of course, they are the first terrestrial animals on Earth. However, they've not been quite successful on land. Therefore, they have evolved evaporation as a means of regulating their body temperature. Besides that, they have evolved two kinds of adaptations in order for them to regulate their body temperature. The first one, we have the behavioral adaptation, and secondly, we have the physiological adaptation. All right. This first one means the various behaviors in which organisms have evolved in order for them to regulate uniform body temperature. Why this one means the various physiological processes attained or some organisms undergo in order for them to what? Adjust their body temperature. Now the question is, what are some instances that actually show that behavioral and physiological adaptations occur in these organisms? Reptiles also exhibit these two types of adaptation. Now the first one we have here is what? Behavioral adaptation. Now under this behavioral adaptation, we shall be discussing burrowing. Burrowing, okay? Now some organisms, some amphibians, such as salamanders, all right, such as salamander. You know, salamanders are actually amphibians. Now they burrow into the soil in order for them to regulate their body temperature, because inside the soil strata, all right, there is high humidity. All right, There's high humidity and low temperature. All right. I know that humidity in the soil varies depending on what season or depending on some factors. Rainfall also tells if a soil has high humidity or low humidity. All right, even the soil strata. The first layer you have the sandy soil. The second layer you have what clay soil. Okay. Now, but on a norm, the humidity inside the soil is higher than that of the one in air or on air. Take note of that. Now, so salamanders actually regulate their body temperature by what? Burrowing into the soil, because the soil has high humidity and what? Low temperature. So that is one behavioral what? Adaptation. Another example is basking. Basking is another way through which amphibians and even reptiles are able to regulate their body temperature. Now, basking in the sense that it is a process whereby organisms, okay, let me restrict everything I'll be saying to amphibians. It is a process whereby amphibians expose themselves to heat or temperature in order for them to increase their body temperature. So the aim of basking is to what? Increase their body temperature. All right. So amphibians bask in the sun in order for them to what? Regulate their body temperature. In order for them to regulate their body temperature. That is what? Basking. That is what? Basking. Another behavioral adaptation is what? Water regulation. Water what? Regulation. Now there are some amphibians such as frogs. These frogs, they are able to take water into their skin. As soon as the water gets to their skin, the water evaporates. Evaporation brings about what? Cooling. All right. So water regulation is a process exhibited by some examples of amphibians, such as the frogs, and it involves trapping water from the atmosphere on the skin. As soon as the water evaporates from the skin, all right, it brings about cooling, which is also another way of regulating body temperature. So these three processes are actually under behavioral adaptation. So I believe it is clear enough. Please let me quickly say this. Let me say this. On land, and unsaturated on land and unsaturated, that is low temperature, on land and unsaturated air, that is low temperature, these organisms lose lots of heat into the atmosphere. As such, their body temperature falls below that of the ambient. Ambient is what? Environment. All right. So on land and unsaturated air, that is, oh, sorry, low humidity now. I'm seeing the right one. I'm writing on that thing. In the presence of low humidity, that is high, that is, I told you just now that high humidity, which means that increase in temperature actually result of what? Decrease in humidity. Then increase in humidity result of what? Decrease in temperature, which means when the temperature is decreased, the humidity increases. All right, that is V's a V. All right, so take note of that. I said that on land and unsaturated air, that is low humidity, all right, they tend to lose a lot of what? Heat to the environment. Because of it, their body temperature, all right, falls below that of what? The temperature of the ambience, that is what? Environment. In order for them to prevent such drastic condition, what do? They begin to look for micro environments. They begin to do what? Look for micro environments. And that is where basking comes in. All right? That is where basking comes in. That is, they begin to look for shades. All right? Shades or shelters and rocks where there's what? High humidity and what? Low temperature. So which means that when they look for micro environment or micro habitat, they are able to regulate their body temperature, because beneath the rock, deadwood or shades, you have high humidity and what? Low temperature. That is, so what I've just mentioned is under what? Behavioral adaptation. It is under behavioral adaptation. So let us now discuss physiological adaptation. I believe what I've said so far is understood. Now, physiological, I said they are the various physiological processes that amphibians have evolved in order for them to regulate uniform body temperature. Okay, so what are some instances of physiological adaptation? Okay, one, okay, you say rate of metabolism. Is that, sorry, excuse me, I don't know these slides. So please, sorry about that, sorry for that, please. Now, rate of metabolism in amphibians is actually low. All right, it is not as high as that of what? Endotherms. So amphibians, they have low rate of metabolism. It therefore means that they do not need or require they don't require large amounts of energy, just as the endotherms, in order for them to regulate their body temperature. That is for that. And secondly, there's one called, they undergo two phenomena called vasodilation and vasoconstriction. All right, vasodilation and vasoconstriction are actually physiological adaptations through which they are able to regulate their body temperature. Now, if I may ask, vasodilation and vasoconstriction, are they voluntary or involuntary? They are what? Involuntary, because it has to do with the flow of blood through the blood vessels. Now, let us analyze vasodilation and vasoconstriction. First thing first, you must put into consideration the part of the brain that actually does this. What part of the brain controls these two phenomena? Alright, please, the part of the brain that controls vasodilation and vasoconstriction is the medulla oblongata. Alright, you know that the medulla oblongata, alright, is actually found in the hindbrain. Alright, it is found in the hindbrain, and it is known to control involuntary or autonomic functions. And of course, you agree with me that autonomic functions are what? Involuntary, and autonomic functions are actually sympathetic, like sympathetic. So which means that medulla oblongata, which is a part of the brain that controls vasodilation and vasoconstriction, it controls involuntary activities or autonomic functions or sympathetic functions. Now, there's a center on the inside of the medulla oblongata. This center is called vasomotor. What did I say? Vasomotor. Now, once this vasomotor is triggered, when it is stimulated, All right, when the vasomotor of the medulla oblongata is stimulated, what happens? It causes what is called vasoconstriction. Now the question is, what is vasoconstriction? Vasoconstriction is a process by which the blood vessels, or the blood vessels are constricted. That is, they are narrowed. All right, the blood vessels are constricted, they are narrowed, which means that when the blood vessels are narrowed or constricted, what happens? It results in what? High blood pressure. High blood pressure. I'm not talking of high BP. No, that's what I'm saying. I mean the rate at which blood flows, it's very high. All right, that is, you know that water passing through a smaller pipe tends to be faster than the one that passes through a pipe with a very large lumen. That's what I'm trying to say. When the blood vessel is constricted or when it's narrowed, it means that the rate at which blood flows is what? Increased. Therefore, now during vasoconstriction, the blood vessels that are closest to the skin vasoconstrict. That is, they are what? Narrowed. In the sense that large amounts of blood is not being pumped into the surface of the skin. Therefore, they are able to what? Conserve heat. Please let me explain this properly. When blood vessels are constricted, all right, the amount or the quantity of blood that passes through is reduced, but the pressure is very high. Don't confuse it all. When the blood vessel is constricted, all right, the flow of blood is reduced, but at a very high pressure. All right, the blood flows at a very high pressure, but the blood itself is what? Reduced, because the blood vessels have been what? Constricted or narrowed. So it's a way of conserving what? Heat. The next one is vasodilation. I said that when the vasomotor is stimulated, it causes what? Vibration. All right, but when it is not stimulated, it causes what? Vasodilation. Now, vasodilation is opposite of what? Vasoconstriction. It means that the blood capillaries that are very close to the skin dilate, that is, they open up. As soon as they open up, large quantity of blood flows into, that is, towards the surface of the skin. Therefore, the rate at which blood flows, that is, blood pressure, is reduced. You see that? In vasodilation, blood pressure is increased, but the quantity of blood that pumps to the skin reduces. But in vasodilation, the blood that flows towards the surface of the skin is increased, all right, but the rate at which the blood flows is what? Reduced, because the blood vessels, the lumen in the blood vessels is very large compared to those of what? Vasoconstriction. All right, so take note of that. So once the blood vessels are vasodilated, all right, large amounts of blood pumps to the surface of the skin, and heat is what? Liberated. Then after which there's what? Cooling. So these are the various processes through which amphibians are able to regulate their body temperature. It is very, very important you take note of that. Okay, is there any points I've not dropped? Right, this, what I've said so far, should be more than enough to actually do well. Okay, that is the little I know. I've been able to say it. If you know, you can actually do more findings, all right, that could be much more broader than what I've just done. So at this point, we'll call it a day. Don't forget that amphibians are ectoderms. That is, most of them do not produce their own energy, but a few do. All right. Then I go vasodilation, vasoconstriction as involuntary phenomena. All right, under the influence of the medulla oblongata found in the hindbrain, a center called vasomotor controls vasodilation and vasoconstriction. So at this point, we call it a day. Thanks for watching. Do have a wonderful day. Please endeavor to subscribe.